Alright, everybody. So, long story short, my children are quarantined. This is a first. It's actually an amazing first because I work in a high school, my wife works at a nursing home, and my children go to daycare. So, it took us over a year and a half to finally get someone in quarantine. So, today, coming live from my house. So, just gonna kind of run through the worksheet with you and make sure you're okay with everything. So, thinking back to geometry, the main thing we talked about in geometry was SOHCAHTOA. Now, main thing we talked about in geometry that relates to trig is what I'm talking about. So I write it like this. Now, what's the benefit of writing it like this? Each setup shows you the ratio you have to make. Sine, opposite over hypotenuse. Cos, adjacent over hypotenuse. Tan, opposite over adjacent. Now, every time we're talking about SOHCAHTOA, we have to have an angle of focus. So here is my angle of focus. Now, from that angle, I'm able to draw two lines. If I draw my line from the angle across, that tells me 3 is my opposite. If I draw a line from the right angle across, it tells me 5 is hypotenuse, leaving 4 is my adjacent. All right, so I always think about these two lines to help me out. All right, so with that, sine, opposite over hypotenuse, 3 over 5. Cos, 4 over 5. Tan, 3 over 4. All right, so those are my three ratios that go based on SOHCAHTOA. Now, you've seen this before. This is something you did years ago when you were in geometry. All right, so obviously we can't continuously do the same thing over and over again. We have to change things up a little bit. All right, so sine, cosine, tangent have reciprocal functions. All right, so cosecant, which we shall abbreviate as CSC theta, is the reciprocal of sine. All right, it is 1 over sine theta. Now, if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. All right, secant, which we shall abbreviate as SEC theta, is the same thing as 1 over cos theta. They are reciprocal powers. Not reciprocal powers, reciprocal functions. So if secant goes with cos, cos is adjacent over hypotenuse. This is hypotenuse over adjacent. Cotangent, COT theta, 1 over tan theta. And if tan is opposite over adjacent, this is adjacent over opposite. So the key thing to pick up here is that cosecant, hypotenuse over adjacent, opposite. Secant, hypotenuse over adjacent. Cotan, adjacent over opposite. And if we take what we're doing up top, if sine's 3 over 5, that's 5 over 3. If cos is 4 over 5, that's 5 over 4. If tan is 3 over 4, that's 4 over 3. All right, so if we look here, again, our setup is based on this angle. Now, this angle N works also, but we're not looking at angle N. We're only looking at angle M. Everything when we're talking about SOHCAHTOA is based off an acute angle inside a right triangle. Technically, it doesn't matter which angle we focus on, but here we're being told. So M, 8 is my opposite, 10 is my hypotenuse, 6 is my adjacent. All right, I'm good to go. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. All right, and from there, we have the letters set up at top, but the key thing is it's a flip. So if sine's 8 over 10, cosecant is 10 over 8. If cos is 6 over 10, secant, 10 over 6. Tan, 8 over 6, cotan, 6 over 8. Now, if we base this off of angle N, obviously our angles will be different, our setup will be different, and we'll have different ratios. All right, so that's what we have there. Okay, so everything we're looking at with trig is based off of these right triangle setups. Right, so we're going to look at two different problems right now that relate to what we're doing. All right, so the first setup of problems we have is what happens when you're given a specific point? Well, if we're given 5, 12, right, from 5, 12, I can create a right triangle, which is key because if we're talking about SOHCAHTOA, we have to have a right triangle somehow factored in. All right, so here we went 5 units to the right and 12 units up to make our triangle. How do we figure out our hypotenuse? Well, if we have a right triangle, Pythagorean theorem. A squared plus b squared equals c squared, which in this scenario, 5 squared plus 12 squared equals c squared. All right, c in the end is 13. Using that info, we can find all of our information. But where is the angle we're focused on? Right, it's always going to be the reference angle. So the reference angle we have is right there in the bottom left corner. So based off theta being in the bottom left corner, if I were to label up my info here, 12 is my opposite, 13 is my hypotenuse, making 5 my adjacent. So sine, opposite over hypotenuse. Cos, adjacent over hypotenuse. Tan, opposite over adjacent. And the ones that go with it, we got the flip-flop going on. Cosecant is 13 over 12, secant is 13 over 5, and cotan is 5 over 12. Right, and obviously it's good to know the setups there. H over O, H over A over O. But knowing one set of trig functions, you could flip them to find the other set. So making sure we got this down. Sine. Oh, my bad. All right, so twisting this up for a moment. All right, if we look here, if we're leaving the whole idea of opposite, adjacent, hypotenuse, what do we actually have? All right, so what is 12? In this situation, 12 is the y value of the point we were given. What is a 13? Well, it's the hypotenuse of the right triangle, but in the scheme of the whole setup, 13 is the radius of the circle. So everything we've talked about with SOHCAHTOA, we can switch back to this idea of x, y, and radius. All right, so sine is y over r. Cos, 5 is the x, 13 is the r. Tan, y over x. And then for the others, we got the flip-flop. R over y, r over x, and x over y. All right, so all these trig functions relate to SOHCAHTOA, but now again, we're putting this trig twist on it. Right? We're putting the trig twist on it where we have that point. 5 represents the adjacent, which is an x value. 12 represents the opposite, which is a y value. 13 represents the hypotenuse, which is the radius in this problem. So the 6 trig functions we have now are sine is y over r, cos is x over r, tan is y over x, cosecant is the flip-flop of sine, r over y, secant is the flip-flop of cos, cotan is the flip-flop of tan. And where does your radius come from? All right, so you got x squared plus y squared equals r squared. So the radius equals the square root of x squared plus y squared. And that's how we will find it every single time. All right, moving on. All right, before we start, here's a key thing to know. All right, so in every quadrant, we have to realize, in the first quadrant, the points are positive, positive. In the second quadrant, negative, positive. The third quadrant, negative, negative. In the fourth quadrant, positive, negative. That looks like a line. Positive, negative. Due to this, we've learned this idea of something called A, S, T, C. These letters are telling us which trig functions are positive in which quadrant. So in the first quadrant, all trig functions are positive. every single trig function is positive because x and y are both positive. In the second quadrant, sine and cosecant are positive. Why is that? What we just learned is that sine is y over r. Being that the y value is positive leads to sine being positive. Right? The radius is always positive. It's a distance. Right? It's a radius of a circle. You never have a radius of -5. Right? So the radius is always positive, which is positive x or y. Right? If we look down here, tan and cotan are positive in the third quadrant. And why is that? Well, tan is y over x, so you'd have negative number divided by negative number, which gives you a positive number. In the fourth quadrant, we got cos and secant. And why is that? Cos is x over r, and x is positive in the fourth quadrant. Alright, so I'm going to put this all to work. Alright, so I'm going to do 2 examples right now. Alright, so if we think about our first setup, a lot of people like drawing the triangles, which is fine. There's nothing wrong with that. Alright, so there we have -9, -12. There's my right triangle, there's my setup. So what we talked about earlier is how do you find the radius? Well, the radius equals the square root of x squared plus y squared. 9 squared plus 12 squared gives us a radius of 15. So we have x, we have y, we have r. So we're talking about sine x, cos x, tan x, and then we got the flip-flops, cosecant x, secant x, cotan x. Alright, sine y over r, -12 over 15. Yeah, you can simplify that down to -4/5. Cos x over r, simplify down, -3/5. Tan y over x, -12 over -9, 4/3. So just based on working this out, A, S, T, C, tan's positive. Well, using the x, the y, and the r, tan just ended up being positive, while the other ones are actually going to be negative. Now we got our flip-flops, -5/4, -5/3, and 3/4. Alright, so there's example 1. Now if we look at example 3, we have the point -3, 0. So it's not really the idea that we have to set up a right triangle. And why can't we set up the right triangle? That's because we're on an axis. But we can still solve for r. Well, r equals the square root of x squared plus y squared. Alright, so 9 plus 0, square root of 9, the radius is 3. So it may not be set up as exciting as the problem before this, but we still have an x, we still have a y, and we're able to solve for r. Sine x, cos x, tan x, cosecant x, secant x, and cotan x. Alright, so if we have, in this situation, cos, we got, sine, we got 0/3 equals 0. Cos, -3/3 equals -1. Tan, 0/3 equals 0. Alright, got the flips. Cosecant, 3/0, what does it equal? Undefined. Secant, 3/3, what does that equal? Still -1. Cotan, -3/0, what does it equal? Undefined. And that's fine. That's, hey, based on what we have right there, that's what we get. Alright, last one we'll look at. Rad 3/3, so we're in the first quadrant. Rad 3, comma, rad 3. The radius equals the square root of rad 3 squared plus rad 3 squared. So rad 3 squared is 3, right? So I got rad 3 plus 3, r equals rad 6. Nothing wrong with that. That's what we got there, and that's fine. So we got sine x, cosine, tan. Alright, I'm going to write these out first. So sine is y over r. Rad 3 over rad 6. Alright, so if I got rad 3 over rad 6, that is the same thing as 1 over rad 2, which if I rationalize is rad 2 over 2. Cos, same thing, rad 3 over rad 6, which is rad 2 over 2. Tan, y over x, rad 3 over rad 3, which is 1. Alright, there's our setups with those. I gave myself some space here. Cosecant x, secant x, cotan x. Right, so if I flip it, rad 6 divided by 3 is rad 2, which is the same thing for secant. And cotan, no matter what I flip, it's still 1. Alright, so this is a setup we have if we're given a singular point. But there's a different type of problem we can have along with this. What happens if you're given a ratio? So we have the same type of problem, but we're not given a singular point. We're given a ratio. So if I look at this setup now, secant theta equals 2 over 1. Well, what does secant equal? R over x. So we're given r, we're given x. We're given two pieces of information, just like the previous set of problems. In the previous set of problems, we were given x and y every time. Here we're given two of the pieces, right? We're not given y. So we have here that 1 squared plus y squared equals 2 squared. 1 plus y squared equals 4. Y squared equals 3. Y equals rad 3. Right, so similar idea, we're given two pieces, we find the missing one, and then we're able to find all of our trig functions. So I got sine x, cos x, tan x, cosecant x, secant x, and cotan x. Well, we already know that secant x is 2. So if I flip that, that means cos is 1/2. Sine is y over r. So I got rad 3 over 2. Right? Meaning that cosecant is 2 over rad 3, which is 2 rad 3 over 3. Tan is y over x, which cotan is 1 over rad 3 for rad 3 over 3. All right, so I got all the trig functions out there, but what am I forgetting? Quadrant 4. All right, so quadrant 4 is telling me ASTC, cos. Cos is positive. So sine is negative, tan is negative, cosecant's negative, and secant's negative. So there are my answers. Right, that's what I got going on in that scenario. Alright, problem 3. Let's do problem 3 together. Alright, so sine equals negative 2 over 3. So why did I give the negative to the numerator? Well, sine is y over r. And if we're talking about negatives, you can never have a negative distance. So the radius always has to be positive. So I got negative 2 squared plus x squared equals 3 squared. So x equals 9 minus 4, 5, rad 5. Alright, sine x, cos x, tan x, cosecant x, secant x, cotan x. Alright, so sine is negative 2/3, which means that cosecant is negative 3/2. Cos is rad 5/3, which means that secant is 3/rad 5, which is 3rad 5/5. Tan is y/x, which is negative 2/rad 5, which gives me negative 2rad 5/5. Cotan, negative rad 5/2. All right, finishing off the idea, ASTC, I'm in quadrant 4, so cos is positive, sine's negative, tan's negative, cosecant's negative, and cotan's negative. All right, so there are our 6 answers. Alright, so I'm going to stop here. I feel like I don't want to just keep filling this video with me doing the same work over and over again. So use this as a guide. Use this to help. There's some examples that are not done by me right now. You have the answer key up on Classroom. Check those over, see how they're doing, and give yourself enough time to start the homework in class and consult with each other and make sure things are going okay. Alright, hopefully my kids are out of quarantine, and I shall see you Wednesday.